Alright guys, we're going to talk about functions today. We've already talked about relations, and let's talk about how relations and functions kind of go together. So a relation is any set of ordered pair, but a function is a special kind of relation. So all ordered pairs are relations, but not all ordered pairs are functions. Alright, I've added some sticky notes in here, so you're going to take notes looking at these tabs. So a function is a special type of relation where the input or your x value have exactly one output or y value. All right, so just put that in your guided notes. And then function. If I'm going too fast, just pause the video to take notes. All right, a function is all x values are different. So each x value has to be different. If you look at this set of ordered pairs, 0, 6, 5, -2, 7, 9, 11, -1. Your x is the first number in each ordered pair. So 0, 5, 7, and 11 are all different, which means this is an example of a function. So it's a set of ordered pairs, which means it's a relation. Now we know it is also a function. All right, an example of something not being a function. All right, it's not a function if all the x's are not different or unique. All right, an example of an ordered pair or relation, a set of ordered pairs or relation that is not a function. So we've got -4, 1, -1, 7, -1, -2, and 5, 6. Again, we're just looking at the x values. If you look at the x's, we've got -4, -1, -1, 5. Because -1 shows up twice, that means this is not a function. Okay, it is still a relation, but it's not a function. All right, let's look at some examples here. All right, so determine whether each relation is a function. All right, so example 1, you're going to be looking at only the x values. You only worry about the domain when you're talking about a function. So if you look at domain, you're going to be looking at my pen quit writing. Let's see. All right, 5, 3, 2, 0, and -1. All right, determine whether each relation is a function. If these are all different, it is a function. So we're going to write 5, 3, 2, 0, -1. This is, yes, it is a function because all the x's are different. -2, 0, 2, 3, and 2. 2 and 2. This one is not a function because the x's are not unique or different. All right, -4, -3, -2, 1, and -3. -3, -3, nope, this is not a function. 1, 2, 3, 4, 5. Those are all different. Yes, this is a function. All right, those next ones are in a table, but it's exactly the same thing. We're looking at the domain to see if this is a function or not. So 3, -1, 0, 2, 3. Again, those are the same, so this is not a function. -4, -2, 1, 2, 5. Those are all different, so this one is yes, it is a function. -5, -3, 0, 1, 2. Yes, that one's a function. 1, 4, -7, 4. 4 shows up twice. This one is not a function. -8, -4, 0, 4, 8. This one is yes, this is a function. 1, 2, 3, 4, 5. Yes, that's a function. The next one is in a mapping diagram. So you've got -3, -1, 2, 4. Those all go to one y value, so yes, that's a function. And number 12, negative 4 goes to 4, negative 1 goes to negative 1 and 7. Because that maps to two different numbers, that one is not a function, so no. Negative 1, 0, 1, 2, yes, that one is a function. All right, so the vertical line test can help you determine whether something is a function or not. All right, so if you have a graph and you want to know if something is a function or not, you can use the vertical line test. And this is what the vertical line test. If a vertical line intersects a graph more than once, then it is not a function. Okay? All right, so let's look at some examples of that. All right, so if you have a graph, this is a very poor graph drawn here, but I've got my x-axis and my y-axis, and let's say we have a line here, and then you want to use a vertical line to go from left to right, and if the vertical line only passes your graph one time, then that graph is a function. So this would be yes, that is a function. All right, let's look at example of one that is not a function. All right, if we have a circle, if you use a vertical line and you go from left to right, it's going to intersect this more than once. If you have a square or a rectangle, or maybe other shapes that are not complete, attached all the way around, but anything that touches more than one time is not a function. So the vertical line test is a good way to look at a graph to see if it's a function or not. All right, determining whether a given relation is a function. All right, so on 14 and 15, you can see that these are just ordered pairs. If I look, this point and this point have the same x value because your ordered pairs come from over, and this one would be over and down, and this one's over and up, but they're still going to have the same x value. So for number 14, that one is not a function because it does not pass the vertical line test. Number 15, if you look, all of these have different x values, so this one is a function because it passes the vertical line test. Number 16, if you run a vertical line from left to right, you're only going to cross one point at a time. So yes, that's a function. 17 is going to cross more than one, top and bottom. So this one is not a function. All right, 18, if you look at number 18, vertical line does not pass. It hits more than one point at a time, so that'd be no, not a function. 19, you're going up and back down, no points across more than once. That one is a function. Number 20, this is a vertical line. Means all x's are the same, so that one's not a function. This one touches one point at a time. Yes, this one would be considered a function.